Hi Harshita, good evening. How are you?
Somewhat okay, sir.
What happened? Still not feeling well?
Still not feeling well, sir.
No, have you taken the medicines?
It's half cured.
Huh?
It's half cured.
अच्छा ठीक ठीक डन गुड गुड जस्ट अ सेकंड मुझे
पांच में भी थी साथ में। पांच में तो होती है एग्जाम करके हम भी चाहिए। साथ में जहाँ मैं पढ़ाती हूँ ना, उनको जो मेरे साथ वो पढ़ाती है, उससे वो पीटी की बहन की। तो वो वहाँ गए थे, कॉफी के ऊपर गोलगप्पे खा लिए, शाम में सुबह स्कूल नहीं गए क्यों, गैस बन गई।
जस्ट अ सेकंड हर्षिता actually I like now I have given the access to share my screen.
ओके सर। लेकर आ गई थी ना सबक थी। तो अच्छा समय लगता। हाँ, तो फिर वो मैं
Okay.
भी एक ही था।
Please tell me the question last question you have done in the class.
So last question I did was 35th.
35th ठीक है.
Sir, actually, can we revise the topics which are coming from my exam now? In this,
Which topic please tell me.
like gravitation, thrust and pressure till Archimedes principle,
ठीक है just a
and
second.
then work energy is excluded.
ठीक है. So let's start with work energy. Let me share some. So do you want questions or the theory part?
So like teach me like theory part.
Theory part. Let me just open it. Give me a second.
Okay. कोई भी ना मेरे मेरे साले साले और कोई बस दिन ना किसकी दिन ना चाह मुन्ना का साले तो
Okay. See. So the first thing in the work energy chapter is called the work. The first topic is called the work done. So in the work done is basically we know that the formula of the work done is the product of the force and the displacement. So whatever you are basically doing something, you're applying some force, and if the body is moving, if the body has some displacement, that means there would be some work done. So work done is nothing but a part of the energy which is stored in our body, right? And next thing about the work done is the scalar quantity. It says scalar quantity along with the SI unit is joules, right?
yes.
So work done could be negative, positive, and zero, right? So negative means if the displacement is in the opposite direction in case of friction. Positive means if the position, if the displacement is in the direction of motion, so the work done would be positive, and work done would be negative if the angle between the force and the displacement is 90 degree. Clear?
Okay, sir.
Great. Next thing is basically the condition to consider the work done is basically it should produce some motion. It's not like there should be some motion and you should have if you're applying some force. Okay?
Okay,
So
sir.
this is positive work done if the angle is, if the both the quantities are in same direction. Work done would be negative if it is in the opposite direction. Work done would be zero if the value the angle between the force and the displacement is 90 degree. I hope it's clear.
Yes, sir, it
And
is.
if we talk about the work done against gravity, Harshita, the work done against gravity is nothing but when you are basically taking a body to some height against gravity, because gravity attracts towards the surface, and but still we are moving it upwards. So that's why the work done would be called as work done against gravity, right?
Okay, sir.
And the formula
Yes.
is mgh. Okay,
Yes, sir.
good.
Sir, actually, I have one doubt.
Please tell me.
For this W is equal to Fs cos theta. Further, my teacher told there will be questions asked. So, like, how will they ask the questions? Like, will they
They'll
give the theta value?
No, they will ask that Fs cos theta is the main. You can say Fs cos theta is the formula. They would say that the force and displacement have an angle of 30 degree. So cos 30 value would be given to you, which is root 3/2. Cos 60 degree would be given to you, which is 1/2. 45 could be given to you, which is 1/√2. So if the values, because you have not studied trigonometry yet, which is in the 10th standard, so they will specifically give the value of cos 30, cos 60, cos 45, because cos 0 is 1, cos 90 is 0, cos 180 is -1. This is we have already discussed. Apart from these values, there are the three values
Yes.
30, 45, 60. So they could give you the values for that. So similarly, you just have to substitute the value of cos
Okay.
30 as 1 by root 3/2. So the final answer would be that. Just like, okay?
Okay.
Yeah.
Yes, sir.
Okay, so these are the questions. We'll discuss the questions as well. Just, so only work done part is there.
Yes, sir. Only work done part is there.
ठीक है. So let me just show some question to you. Uh,
कर दिया.
okay, please do 25, 24, 25, 24, 26. Three
Okay.
questions. Please do. Just give me 2 minutes. I'm turning off my video. Just give me 2 minutes. So,
Yes, sir. Sir, actually, we've done these questions actually.
we have done these questions.
Yes, sir, we have done work done chapter before the fourth chapter.
ठीक है.
I think we did it till the 50th question.
ठीक है. No issue. Just please. 1 second. 1 second, Harshita.
Okay, sir.
1 second, Harshita. Let me take another questions. Okay, let me discuss the gravitation first, because let's discuss the gravitation. So in gravitation, you have problem in thrust and pressure, right?
Yes, sir.
Okay. Now, if we talk about the pressure, so pressure is basically the force which is acting perpendicular to the area, right?
Yes, sir.
Okay. And the formula for the pressure is basically force upon area. And the SI unit of pressure is basically Newton per meter square or Pascal. Two formulas are there. Okay.
Okay.
And if we talk about the force, basically, so different force produces different pressure depending on the area, right? If you also basically provide same force, but different areas are there, so that would basically also produce different pressures. Clear, Harshita?
Yes, sir.
Right. So the force acting on the unit area is directly proportional to the force. So if you increase the force, the pressure would increase. If the area, so area is inversely proportional to the pressure. That means if you increase the area, the pressure would be small. If you decrease the area, the pressure would be high.
Okay, sir.
Okay. Now, if we talk about the next thing, so when a force act on a large area of the object, it produces a small pressure. But the same force is acting on the small area, it would produce large pressure. Okay.
Okay, sir.
Great. So in terms of thrust, thrust is nothing but the force which is perpendicular, right? So in the terms of pressure, we also write force as thrust, right? Because whatever we are basically producing a virtual, not virtual, basically perpendicular force. Okay?
Yes, sir.
Good. And day-to-day life, we have seen in the pressure as well. School bag has wide strap, because because if the pressure the strap are thin, they would harm your shoulders. So that's why they are made with larger area, so that the pressure is small on the shoulders. Okay?
Okay, sir.
Next is sharp knife can easily cut the vegetables, butter, or anything because of the small area. The pressure would be high. But in terms, if the
Okay.
blunt knife is there, that would not cut it, right? Next is
Yes,
the
sir.
tip of the swing needle is sharp, so that due to its sharp tip, it easily stitches the cloth. Otherwise, it would tear apart it.
Okay, sir.
And if we talk about when the man is walking, uh, so at one time only one feet is on the ground. Okay?
Yes, sir.
And so that means the pressure would be high, because if you're standing, the 2 feet would be there on the ground. So that means the weight will be distributed over the 2 feet. So that's why the pressure would decrease by half. But on the say a single foot, the pressure would be larger. Okay?
Yes, sir.
Tractors have broader tires. Why? The reason is because the soil is very loose. So that's why the tractor might basically, you can say, sink into the soil. So to avoid that thing, we make larger tires, broader tires to basically decrease the pressure. Okay, Harshita?
Yes, sir.
Good. Just give me a second. Let me find out the book, because I have the book. Are Harshita, have you done 61st question? Just let me know if you have. 60.
Yes, we have done this.
ठीक है. Just give me a second then. Okay, Harshita, please do the question number 19th.
Okay, sir. There is the work done negative 7,000 joule.
Negative 7,000. Yes, correct. Please let me know the 20th question.
Okay, sir. So isn't 0 joules?
0 joule.
Yes, sir.
Yes, correct. The reason why?
So it's because he's just like standing on the road at a 90-degree angle. So it's 0.
Yes, correct. Because the 90-degree angle. Just a second, Rashida. Let me find out some more questions. So you have thrust and pressure only for gravitation, like whole
No,
chapter.
sir. Uh, the after the thrust and pressure also.
No, so basically the whole chapter is there, na?
Uh, no, sir. Like from thrust and pressure, Archimedes principle is there.
अच्छा ठीक है. Please do question number 9, Harshita.
Okay, sir. Sir, is the answer 350 grams?
Yes, correct. It's 350 grams. Okay. Because the
Yes.
CGS unit of density is gram per centimeter cube. Okay, please calculate the 12th one.
Okay, sir. Sir, is the upthrust 0.98 Newton?
Yes, correct. Good. So it's nothing but the formula in which we have to calculate the mass, then acceleration due to gravity will be multiplied with it. Good.
Okay, sir.
So these are the questions basically related to Archimedes principle. Okay?
Okay, sir.
Good. Just calculate this one, 20th.
Yes. So is it 1245.3
1000?
245.3 Newton?
No, Harshita. Please check your calculation.
So I got 1340.6.
That is right, but there is the question is there should be weight as well, na? The body is also droning, na? So the upthrust is what? Upthrust is basically the difference between the actual force, the net upthrust minus force, the weight. So you have to subtract the weight as well, 830 Newton after filling H2.
Okay, sir. There is it 510.6 Newton.
Yes, now it's correct. 510.3 Newton.
Yes.
Good. Let me know the answer for it. What makes a body to float or sink in the liquid with proper factors?
Yes, teacher. Complete. So, yes, sir, completed it.
Yes, please tell me.
So body floats when density of the object is less than the density of the liquid,
Okay, and
and
next.
a body sinks when the density of the object is more than the density of the liquid.
Yes, correct. Good. Okay, please tell me the answer for this, Harshita. And one more thing, don't think that tension is a different thing. Tension is nothing but it's asking the net upthrust in terms of tension, right?
Okay, sir.
Yeah.
There is a 94.08 Newton.
No, it's 62.72 Newton, Harshita, because the volume is given and basically your density is given. From that, you can calculate mass. And if you talk about the weight, so weight would be 9.6 into 9.8. Okay. And so whatever the weight would be, it will be nothing but the upthrust.
Okay, sir.
Okay. So no issues. Just a second. Calculate this 24th question, Harshita, please.
So, but for this question, I did like I multiplied the length and all, like the 0.20 into
Yes.
0.30 into
You
0.40.
have done correct. But after that, you also have to calculate the mass of the water displaced. So mass of the water, how can you calculate it? Volume of the block and density of water. So whatever the mass of volume of the block would be, will be equal to the water displaced, yes or no?
Yes, sir.
So density of water is 1000 gram per meter cube. So in terms of mass, it would be 16 kg. So if we wanted to calculate the weight of water displaced, that would be 16 g. So upthrust is 16 g, okay, and weight of the block is 9.6 g. So how would you calculate upthrust? Net upthrust, total upthrust minus weight. So how would you calculate 16 g minus 9.6 g? So in total, the upthrust would be 6.4 g Newton. So multiply with it 9.8, you will get 62.72, or 10 meter per second square. You will get 64 meter or 64 Newton. Okay?
Okay, sir.
Please do the 24th.
Sir, is the weight 2817.6 Newton and acceleration 1.8 meter per square?
Acceleration is 2.3 in the upwards direction, and the calculation of the weight of the balloon would be 2820 Newton. It seems like you have taken 9.8.
Yes, sir, I've taken
Okay.
9.8
So
because as
what is the weight net upward force? Because ultimately you have to cancel the weight of the balloon to calculate the upthrust, net upthrust. That would be whatever the value of the weight of the balloon would be minus weight of the, just a second. So this is the balloon density, ठीक. So that would be given to you as weight, ठीक. Weight of 12,000 meter of air in the balloon and weight of normal balloon. So it should be 2820 Newton. Did you get the same answer?
no, sir, I did
What
not get
what
that.
answer did you get?
So I got 2817.6.
17.6. You were very close. Maybe some calculation mistake.
No, sir, I've gotten 14,817.6 and I subtracted by the 12,000.
So have you taken G as 9.8 or 10?
9.8 I've taken, sir.
9.8 the calculations, but still you are very close. It's 17 and 20 is not that much big difference. And what is the acceleration you have got?
1.8 meter per second.
1.8. That is a little bit different because it's 2.3. Okay, no issues. Please take your calculation. Take the screenshot of it.
Okay, sir.
Check out this. Okay.
Cheers, sir.
So great. So okay, Harshita, we'll meet in the next class. When will be your exam? Please let me know.
Sir, we didn't get the timetable yet for the examination, but I think it's on 18th.
Chicken, no issues. So till then, please do the revision and keep revising and practicing. Till then, take care. Bye bye. Good
Okay.
night.
Thank you, sir.
Welcome.
Bye, sir.
Hi Navid, how are you?
Hello, DJ. I'm fine.
Okay, circles we are doing, right?
Yeah.
I'm sharing the screen.
Yeah. Teacher, my mother had sent the team about the maths portion and the dates. Did you get it?
Yeah, I got the message. Okay,
Oh, okay.
regarding your exam and the